don't write out the formulas. I don't go through all the long-winded definitions because these three formulas are kind of like a subset of what we've already done. It's a different way to look at a problem given specific information. So these three things will always work within similarity, but these three different ways that we look at it today occur with a certain type of diagram. So if you recognize the diagrams that I draw out, anytime you see them, just kind of fall back on this plan here, okay? For example, one of the things that we can do is if I take a triangle, if I take a regular old boring triangle, and I pick one side to draw a segment parallel to it. Doesn't matter which one I draw, but let's say I draw a parallel side from here to here. And then make these two parallel to one another. What that parallel line through the triangle does, if you look closely, it creates a segment here, a segment here, a segment here, and there. It creates 4 segments, doesn't it? Now, if I take this parallel line and extend it, doesn't it look kind of like a fraction bar now? It takes the two sides and creates a fraction. A over B equals C over D. The reason that this works is because you have two similar triangles here. You have that shared reflexive angle, if you will, at the very top. And with parallel lines, you wind up getting corresponding angles. It's just a shortcut way to do this. There's going to be times when we get a couple of shortcuts thrown our way, and this is one of them. So what happens if you happen to see a diagram where you have a triangle and one side is parallel to the other? It's creating fraction over fraction equal fraction. It's creating that by doing that. Okay? It's a great shortcut. I'll show you an example here numerically of what it would look like. And the reason that this is working is because of the similar properties of angle. You have that shared side here. You've got corresponding angles here and here. You have corresponding angles here and here. That's why that works. It's just a shortcut way of doing it. Okay. It cuts the sides of the triangle into 2 parts, and it cuts it into fractions. Okay? Let me show you what it looks like with numbers and things and stuff. If I look at that, I've got a triangle. I've got a line, a segment that's inside the triangle that's parallel to another side. Now, depending upon which way I tilt, I have a missing side length on one of the parts of the triangle. So that missing side length is that segment AB. So if you look at it, this portion here is creating the fraction bar. There's your unknown. If you tilt your head that way, you get 5 over x is 6 over 12. If you tilt your head the other way, you get x over 5 is 12 over 6. Does it matter which way you tilt your head? No. 5 over x, 6 over 12. What's x? 10. It's a great shortcut. That's what I'm looking at today. I'm looking at shortcuts. Okay. People have been asking earlier today, like, what? Is it really that easy? Yes, yes it is. Pretty much. There's one example I'll do at the end that has a couple more parts to it, but for the most part, it's just a matter of, can you manipulate the graph in such a way to look at it in a different perspective? Okay? Can you look at it in a different perspective? Another one. I go to a clean one here? Waiting. I didn't say anything. Why are you giving me it? I was trying to be. Okay, glad. I was trying to be nice and helpful. So let's say you have three parallel lines. Oops, that's not. I know it's not. Let's say you have three parallel lines.
So it's not only the triangles?
Nope. So you have three parallel lines. Let's say you have three parallel lines, and those three parallel lines are cut by two different transversals. So if you have three parallel lines that are cut by two different transversals, you got a whole bunch of stuff going on there. But what I want you to notice is that on the inside of the three parallel lines, isn't there just two segments on the top and two segments on the bottom? You guys agree with me on that? So, depending upon the way you spin around and whatnot, can't I also say that that middle parallel line is like a fraction bar? Well, I'm going to, and I want you to treat it like it is one. Because if you do that, A, B, C, D, tilt your head sideways, B over A is D over C. Or if you tilt it the other way, A over B is C over D. That's all it is. Three parallel lines. Cut by two transversals. This middle line acts like a fraction bar for this segments. So you get this fraction, A over B, C over D. It's a really nice shortcut as opposed to showing you guys the extremely long-winded and annoying definition for all of this. It's exciting. Keep it going. Poor Ezekiel thought I was talking about him right away. See how fast his head popped up? It's not always about you, my friend. Let me show you an example. I have three parallel lines. I have the three parallel lines. Those three parallel lines, that middle line, treat it like it's a fraction bar. Tilt your head one way or the other, and you can see, well, it's either be 6 over 8 or it's going to be 8 over 6, depending on how you write it. Hmm? What? It's just 3 of them, and then 3 of them are parallel and 2 of them aren't, so it's just 5. You only need, 1/4 of your digits to count it, unless you've got extra digits or missing digits out of this. Think about your toes, some people miss a toe. Sucking the life out of me. So again, if you just tilt your head a little bit off to the side, or you'll notice you get 6/8 is x over 10. Here's your fraction. There's your fraction. What's wrong, Thora? You went cross-eyed there too.
Well, at first I was looking at it like this, and I looked up and I was like, what?
Well, if you spin it the other way, is it the same if you did the other way? 8/6?
Yeah, but I was just confused. I thought I wrote it that way.
No, because I just move it around a little bit. It means the same thing. It just depends. It literally just depends on how you read it. Yes, ma'am.
So the order doesn't matter?
As long as you're consistent. So if you go this way, you kind of tilt like that. The 6 is on the top and the x is on the top because they're further away. If I go this way, it's working this way. So it has to be the 8 and 10 on top. Okay. So you cross multiply out, you get 60 is 8x divided by 8. You get 7.5. Is it okay to begin a decimal? Yes. Because what does 6/8 simplify to be in terms of a fraction? 3/4. Good. Now, if you take your calculator, do 7.5 over 10, it should give you some fraction. I don't remember if it does for this one or not, but do you guys know how to, if it gives you a decimal, do you know what button to press to switch it?
Double arrow.
The double arrow. Very good. Yeah, the 4th hour didn't know that double arrow existed. They've been overlooking it all this time. Because you overlook it as you press enter, because it's right on the way to pressing enter. You're going to love this next one, Miss Hope. I know of anybody in this room, you're going to love this next one the best. Why do you have to crush my hopes and dreams?
Because you crushed hers.
No, I didn't. No, when did I? We high-fived earlier today. We're all good.
Is it all good?
Sure. I'm trying to start today. I'm trying to start off on a new positive note with you to encourage you to.
Not me.
Nobody likes you, so that's
What do you
okay.
mean my friend?
No, I wasn't. Here's the other one.
Oh, wait.
Waiting. I was joking. We do like you. It's your brother we didn't like.
Yeah, probably.
Did you like my
Okay. He tried. He tried to match wits and it didn't work. Well, that was my fault. Triangle. If I take a triangle and I bisect an angle, I get something like that.
You haven't used any words on our notes.
No.
It's always the pictures. Thanks. We're not friends anymore. We're not friends anymore.
So what I'm trying to get, and you're right, I'm not trying to put down a lot of this in words because if you recognize the pattern, you look at the pictures, and you can kind of piecemeal some of this stuff together, that's good. Okay? Now, what I want you guys to think of is that you've got this angle bisector. And if you look at it, the angle bisector kind of creates two parts of the triangle. A part up here and a part down there. So what happens is, I want you to, where's my, I want you to love this triangle. Because if you love this triangle, you go out of the angle bisector, and it gets two fractions here and here.
Oh. Okay, good. No.
So you have angle bisector. Oops. Angle bisector. Go out the angle bisector and around. Go out the angle bisector and around. It looks like a heart. Here's the numerator, there's the denominator. Numerator, denominator. A over B, C over D. So the analogy of loving angle bisectors creates fractions. I know this one is really a stretch. But if you have, anytime you have an angle bisector, you have an angle bisector. Yeah. If you have an angle bisector, start where the angle was bisected, go out and around. And you get fractions. A over B is C over D. Now I told you, you would love that. You don't love it?
Teach this lesson again.
Should do what?
Teach this lesson again.
Yeah, it is a little bit off timing for us right now.
My brother's birthday.
So here's an example of what that would look like. All you have to do is recognize that you've got the angle bisector and you've got side lengths going around it. If you draw if you put a little love in your heart, you'll be able to create the fractions. I'm really trying on this one.
I appreciate your effort.
Thank you. Thank you. And I know it's stupid, and you're going to look Murphy, you're so good. Out and around, you get x over 9, 8 over 12.
This way? That way? Wait. Why not 9 over 9? Or 12 over 9?
If you go the other, it's what I want you to remember whenever you draw it out. You always start at the angle bisector. If you keep this in mind that the first segment is always the numerator, the second is the denominator, that way you never accidentally flip-flop it. So you're going out to the numerator and you're coming back around to the denominator. Even though it was placed, even though we drew it this way, you're still going out and around. Out and around. Just remember that the one on the out is on the top, around is on the bottom.
Okay, because I read it like the other way.
You're not wrong. I know that people will flip them. They're not careful. So you always remember that you're looking out at the numerators and coming back to the denominator. What's that? I was dead on Monday, remember? When they did inverses? There you go. So when you do this one, you had what? Cross multiply, you get 12x is 72. X is? I know it's the dumbest thing known to man to do it this way. But you still make those things? But it's just a very easy, very visual in how to set it up. Okay. Let me show you the mixed up version of this with a whole bunch of extra parts put together in it. Now take a couple of seconds here and really try to draw this one out nicely, because this example does a huge job in incorporating a bunch of different properties that we've worked with. I'm going to blow it up here and give you guys a second to draw it out. Take a couple minutes here to draw this one out, and then we're going to try to split. Can't just be super easy all the time. I gotta make you guys think a little bit, like a little. You know, I'm asking that.
There's so much going on.
Alright, so once you get going on this, it's just a matter of picking a place to start. Now, notice you've got that red line through everything, which is an angle bisector. So you've got your angle bisector. So what I'm gonna move this down a little so I have a little more space to work. Come out and around, out and around. So the first part you're gonna love. You have d over 6 is 3 over 9. Hey, what does 3 over 9 simplify to be? 1/3. So knowing that these triangles are going to be all similar, they're all going to have that scale factor of 1/3, 1 to 3. Okay? So I can do this a couple ways. I can say is 1 over 3, cross multiply, I get 6 is 3d, d is 2. Or 18 divided by 9 is also 2. No big deal. Okay? Now, that gets me to the first part. So I have a 2 here. The second part, I still have that angle bisector where I can go out and around. I have a b over, now this side length is 12. Here I have a 6 over 9 plus a. This is where it gets a little tricky because you can't cross multiply and solve with two different variables. But you know that triangles are similar because of that angle bisector. So you can go back and continue to use the scale factor. That first scale factor was what? 1/3. So what I can do then is set this part equal to 1/3, cross multiply. Set this part equal to 1/3, cross multiply here, and cross multiply there. That's how you start to split up these bigger style problems where you have multiple variables. You can continually use scale factor. Okay?
Wait, why would it be 9 plus 8? Why would it just be 9 plus?
Because you're adding. If I have 3 feet to go, I go 4 feet. I didn't go 12 feet. I went 7 feet because I add them together. Because we're just walking distance. Okay. So b here is 4. Cross multiply this one, you get 18 is 9 plus what? Well, what's A? 9 plus
Oh,
what?
9.
Yeah, you put 9 here. And then I have one more to go for. I'm loving this problem for the third time. This was a 9, this was a 2, this was a 4. Go out and around, out and around. 5 over 12 plus C, because we have 6, 6, and C. On the other side, it is 7.5 over 9, 9, and 4.5. 18 and 4.5 is 22.5. It just didn't show up. Do I have to leave it as that fraction, or could I simplify it? Shouldn't it still have the same scale factor of 1/3? It does. Yes, ma'am.
How did you get the one below the 7.5?
I went out and I came back. 4.5, 9, and 9.
Okay, I didn't see a pink dot, so I thought it was.
I hit it and something else showed up.
Okay.
That's all. 7.5 over 22.5 is still 1/3. You cross multiply it. And you get C is 3. That's how this stuff works. You go out and around, you look at, are you creating fractions within the shape, within the parallel lines, you're adding parts together, you're using more than one trick to make it go, okay? Ouch. Questions? Very exciting stuff. Let me give you the moment. I think I already posted it.
So you're just basically going in small heart, medium heart, big heart?
Kinda.
Oh yeah, like a French.
Do these, please.